So this lesson is for 3.3.3 and 4 will be the quizzes. It's a pretty simple section, hopefully. I'm just going to go through some basics of it, and hopefully this will be pretty quick. Congruent figures have exactly the same size and shape. This is all about congruence. Congruence is another word kind of for equals. So a congruent segment have the same size, and they have the same shape. Okay, so if a triangle is congruent to another triangle, they should be the same size, and they should be both triangles, because a square would not be congruent to a triangle, because that's silliness. Congruent triangles have the same side length and angle measure. So you might see those in a quiz. It'll be like, what makes something congruent? Same size and shape, same side length, same angle measurement. It's both. Okay. There's a couple different types of, we call them transformations, we can do that move something along a straight line, okay, or that move something in a way that they stay the same. The first thing we can do is translate something. Okay, you can think about translate like language. You move from one language to the other. It's just a slide. You slide something over or move along a straight line. And I'm going to show you some pictures of them in a second. The next thing we could do, we could take an image. So say I took this screen. I could flip the entire screen, or I could spin the entire screen. And that's going to be a rotation. It won't change what my screen looks like. It'll just change which direction it is. And finally, the last thing I can do is I can reflect something. And this one you can think about a mirror. The size of your face doesn't change. It's just being kind of flipped. Like you're still seeing the same size. So just so you can see them really quickly. A rotation turns something. You take the triangle and you spin it around. The size didn't change from one side to the other. It's just being moved by spinning. A reflection flips it. Okay, so you go from here. You can also think about a mirror with this. Like your nose will be the biggest thing in the mirror because it's the closest thing. See, that's why it stays close. Your hair is further away. It stays further away. And then finally, translate. You translate your furniture all the time. You move something, you just slide it. Because you slid that chair, it didn't change size, so it stayed congruent. Okay? Why are they called congruent transformations? Because you move them and they stay the same. I'll leave some of these written ones and just move on to some of the practice. If two triangles are congruent, all three corresponding sides, I can do this, I promise. And I'm sorry, I'm not the best at this. Sides and three pairs of corresponding angles are congruent. So if two triangles are the same, every single part has a matching part. And that's what you see here in this practice below. Okay? So first to highlight here, I'm not sure if you can see it too well, but they have triangle M and O, and they have this marking before triangle RQP. This marking right here is our congruent sign. So it's just an equal sign with a fancy little thing, a little top hat. It just really means equal. But what's really fun about these is when you write a congruent statement, you already match up all your parts. Okay? So if I look here, M is my first thing here. Here's M. R is the next thing. Here's R in the other triangle. See how they both have just the one arch? They match with each other. If I go on to the next one, N and Q. N is up here, it has 2 marks. And Q is here, it also has 2. And you should see that O has 3 and P has 3. So they match up really well. Like you have to write them in order when you're writing a congruency statement. Okay? So what it wants us to do down here is just write down all the congruent parts, basically. the corresponding vertices. So M, we've already said matches with R. Well, N and Q we've said match. And Q. O has 3, P has 3, so they match. P and O, whichever order you want to write them in, it doesn't matter. And I can tell M is first, R is first. N is second, Q is second, O is third, P is third. They should match. Next, it wants me to do corresponding sides. Okay, they start off with M to N, which is this side, and QR. Well, look, that has 3 markings. This has 3 markings. That's all you got to do. So if I want to do my next one, I do N to O. So that'll be this side. So I'll write that in, N-O. Doodle-doo. What does that match with? It has 1 marking. The one with 1 marking over here is Q to P. Q, P. And then you would just do your last side, which is the one with 2 markings. So that is M, O, congruent to R, P. And angles are basically the same thing you have going on with your vertices, only you put the angle mark in front of it. So angle, M and R match, we've already stated that. N should match with Q. Congruent. Sorry, it's a little messy. N matches with, we said Q. And angle O is congruent to angle P. So it's just finding the mate, like the match. Okay? That's what congruency statements are all about. That's it for today. We'll practice with this tomorrow, and hopefully this will be easy. It's just about writing it in and knowing the different types of transformations.